All right. All right, we are perfectly on time for the afternoon session. So we'll start with a survey talk by Marc-Olivier Buap from Nokia Bell Labs.
Thank you. Where is the command to move the slide? Okay, okay. Perfect. 1 minute. Let's see. Okay, perfect. Okay. So, hello everyone. It's an honor to speak to this large and clever audience. To start gently, this talk won't be research. There won't be maths. There won't be complex stuff. It's more about ourselves as human beings. So I hope that everyone will feel concerned. I hope that the people that are on their laptop will pay attention at least for the 5 minutes, because we are all concerned by this stuff. So the question is, we are researchers, we are technologists, we can't save new means to use our computers to provide some services. The question is, can we do this well? What is the impact? When we conceive something, do we think about the rebound effects? What are the consequences of our choice, the way we work, etc., etc.? So the purpose of this presentation is about this, about our choices. And so the question is not, are you a good researcher, or a bad researcher, or whatever? The question is, are we moving to the right direction? So here I will talk more specifically about green AI, but the reasoning could be applied to other domains, more generally in anything in ICT. So, and moreover, I will more specifically focus on energy consumption, but I will spend some time to explain that this is not the only problem. So the first part of this talk will be green AI, why it matters. The second part will be about how we can measure the footprint of AI and machine learning. The third time will be a solution to reduce the energy consumption. And the last step will be a recommendation. So as you know, AI is used everywhere. And AI is energy hungry. This is not a big news. So there are some numbers. So we estimate that this is roughly 5% of the total energy consumption, which might seem not so big, but actually it's quite big. It's hard to have good estimation because, unfortunately, few people measure their energy consumption and report it. So it's hard to have a good estimation. We'll see that the methodology to measure this is complicated, which is also a problem. So likely this is underestimated. And so I will try to give number and intuition of what are those numbers. So AI ML, as you can see, this is between 85 and 134 terawatt-hour in 2023, which is small and compared to the entire ICT. So we might say, is it a big problem? I don't know. So actually, we are talking here just about the consumption of electricity, but what you have to understand is when you run AI ML, you require GPUs, you require devices, you require manufacturing, and this is what increases the bill. So this is very important. And so what is 1 terawatt-hour? So this is a quantity of energy that is required to power 95,000 US homes, which is a lot. So still, even if compared to the ICT global consumption, or even worse, the whole world human consumption, this is still huge. And so one question is also, is it so worth to spend so much energy knowing that we lack of energy? So why such a consumption? So the first aspect is that AI is widely used. This enters in all our devices, all our applications. This is very trendy. This allows manufacturers to sell new devices. This allows software providers to sell new software. So this is a cash machine. We have to be fair about this. And also we try, just like the mobile phone 20 years ago, to make understand that, yes, you truly need AI. You must use AI. This is important. You can't live without AI. But if we recall well, for the older people, when we were young, we didn't have AI, we didn't have a mobile phone, and we were quite happy. So it's maybe not so mandatory. Okay. So what about this energy consumption? So according to Google, so maybe you will confirm. The training is only 40%, and according to the newer number, it's even 30% of the total bill. And so, which means that 60 or 70% is used by the users. So we could say, okay, we are researchers, we have designed the tool, we are not responsible about the usage. Yes, you are, because when you release a product, you hope that it will be used. So you have to think about this. So why is it a problem? So the problem is the more we use AI, the more we require GPU. The more we require GPU, the more we require data centers. The more we have data centers, the more we are inclined to use AI because we are more data center. And so this is an infinite loop. And this is a problem. Why? Because often the energy that powers data centers is not carbon free, not at all. So you have a tabular on the right, on the top right side of the slide that shows you that, for example, in China, you rely a lot on coal, for example. And same in United States, significant fraction of the energy is fossil energy, which is a problem. So as you know, if you use fossil energy, you will reject CO2, you will contribute to climate warmth, so it's a problem. It's not the only problem. When you deploy a data center, you have to cool those data centers. So you might think, okay, the water will be slightly hotter. Is it a big deal? Yes, it's a big deal because it contributes to warm the climate. And also it interferes with the ecosystem where you release the hot water. So yes, this is a problem, even for water. But we could add to this list all the abiotic resources, so all the components that are involved in your computers. And this is a problem because as we are unable nowadays to recycle efficiently our devices, this means that we continue to drill new resources. And the problem is those resources are rarer and rarer. And often they are, surprisingly, in area where you have some geopolitical problems, and probably both of them are correlated. Which means that when we deploy new software, more GPU hungry, more CPU hungry, more resource hungry, we contribute to this. And so we have a responsibility. So there are also all the land use aspects, especially for harvest the resources, because you destroy ecosystem when you get those resources. So this is all those problems that are pointed. And so a solution, for example, to say get more power, more power, but without relying on fossil energy, could be to rely on renewable energy or nuclear energy. And so we can see on the Google website that, for example, there are discussions to power some data center using nuclear plants, which is a question. So maybe this is useful to use nuclear energy to power data centers. Could we use this energy for something better? This is questionable. So why do we consume so much energy? So the problem is in the last decade, the goal of AI was to build models that were more efficient and more efficient. And the problem is to get this improvement, often we have to pay for more neurons. More neurons means more energy to train the model. And so here you have a log-log plot that shows the evolution. So what is interesting is the cost increases exponentially. The cost in terms of training and in terms of money that you need to spend to train the model. And so, of course, at some point you will reach a limit. You won't be able to build bigger and bigger model. So this is a problem also in terms of money. If money doesn't convince you, there is also the legal aspects. So there are more and more regulation from Europe, from United States, from India to force the firms that have data centers to report about their GHG emissions. So GHG is greenhouse gas emission. And so we can suspect that the idea behind is once you can monitor this, you can say, okay, you pollute too much, so you have to pay for this. And so when you start to attack the people on the money, they start to listen. So I think it's going in the right direction, and I think it's mandatory because this is the only way we can constrain people to say use less energy. Us, as researchers, we can provide more efficient tools, but it doesn't mean that actually we will decrease the bill. I will come to this later. So at Nokia, it also matters. So I am from Nokia. It also matters because we have an ESG, like many firms. And so we have objectives to reduce our GHG emissions. And so actually reaching those goals is not so easy. So we have to pay attention to this because our clients pay attention to this criterion. Are we doing the thing the right way? And so I think it will become more and more a selling argument. We have to do the thing the right way. So now, how can we measure the energy footprint of an AI? So it depends on what you want to measure. So there are three main metrics. So there are the quantity of CO2 that you emit, which is what you try to minimize in the end. And so you have some algorithms, so MLCO2, cut carbon, gradient algorithm, etc., that measure the quantity of CO2 that is released by an inference or a training. So if you remember, it depends on the country where you run your AI. If you are in China or in the United States or in Poland, you will rely massively on fossil energy. So of course, for the same task, you will pollute more. On the contrary, if you run your AI, I don't know, in Canada or in France, because you rely on hydraulic or nuclear energy, you will pollute less. Then there are the watts, so the power that is consumed by your algorithm. And so there are some tools like PowerTop, NVIDIA SMI, or the underlying package, which is PyNVML. The problem is when you measure this, often this is hardware dependent. And so you don't necessarily have the ability to get those values. And finally, there are the flops. And some frameworks allows to retrieve the number of flops that is consumed by computation. So for example, you have TorchStat, TorchOp counters that is built on top of Torch. You have FVCore, you have Keras flops. But first, the problem is it depends on the software that you use. So do you use Torch or do you use something else? Does the tool exist or not? And often you don't have this metric. And unfortunately, for modern AI pipeline, most of the time you don't have this value. And that's why it's so hard to estimate the energy that is consumed by AI. So now let's talk about the training. So here we have some models and where we have the number of parameters and the quantity of CO2 that has been emitted to train those models. So you can see that it's a lot. So for example, training Llama 2 or GPT-3, this is 550 tons of CO2. But to capture 1 ton of CO2, you require 55 growing trees. So you have to plant many, many trees. And of course, those trees will grow during 20 or 30 years. So which means that when you pollute immediately, you can say, okay, I have planted many, many trees. That's very, very nice. This is very good. Continue to plant trees, but it will take time to actually amortize this price. So that's also a problem. It's not enough to say I have planted trees. You have also to consider that trees requires time to grow. So if you don't know what is 1 ton of CO2, so there are some equivalences on the right-hand side. So there are many websites that provide you this kind of equivalences. And so now the question is, okay, we have talked about the training, but what about the inference? And so here we have a problem. We can see several ways to do searches on the internet. So for example, using Google Search, using ChatGPT, using Bloom, or using AI-powered Google Search. So this is currently what we have nowadays. And you can see that for a single query, the cost increases. And so this is a problem because you continue, for example, to do some research because you want to find a Stack Overflow thread, for example, and you were used to use Google to find the right thread, for example. But nowadays, for example, when you use, so sorry for Google, but it could be other tool. I have no problem with Google. They are doing great stuff. I want to precise. But the problem is sometimes you run your search and it generates, it calls generative AI. So it generates a paragraph, some images. So it's very nice. Sometimes it's very convenient. But sometimes you just don't require it. And even worse, you know by advance that you are not interested by it. So I launch a call. It would be nice that when you run a query, you say if you want or not the generative AI part. And unfortunately, nowadays, it's enabled by default. So just for your information, if you pay attention to this, there are ways to craft the URL query, the URL that you have in your browser, so that you are sure that Google won't trigger the generative AI part. So this is feasible technically. You have to pimp your search engine in your Chrome parameters or in your Firefox parameters, but this is not. This is for say advanced user who knows how to customize their browser. And so this is a problem because I don't know, my grandmother is unable to do so, for example. So this is a problem. And so I think that it's important when we release an AI system, even if this is useful, it can save time and possibly in some case save energy. It's important to think about rebound effects. So will I have a positive impact or not? This is something that we should always ask ourselves before releasing something. Okay. So now how to save energy. So here we assume that we have a legislation that constrains the quantity of energy. Why is it important? Because there is a well-known paradox, which is named the Jevons paradox, which states that the more you are efficient to do something, the more you tend to use it. So basically, what I say is, if we build very efficient AI pipelines, what will happen is people will more and more rely on AI because they will think in their mind, oh, this is cheap, I can use it. But in the end, the bill will be higher. And so this is a problem because us as researchers, we try to propose more optimized models, more efficient models, etc., in hope that we will save energy. But if in the end, the people will tend to use more energy, in the end, this is not worth. So here, the main point is, in my opinion, when you try to optimize some models, this is under the hypothesis that you have a limited budget, and so you want to do more given this budget. So here, this is rather the purpose of this slide. So how can you do so? So there are several techniques in machine learning that can help you to optimize your model. So for example, the pruning, the idea is to remove all the useless neurons. And so as the model is smaller, it is more energy efficient. So according to some reports, it can save between 30 and 50% of energy. Then you have quantization. The quantization, the idea is instead of using the weights in your neural network with high precision, you will decrease the number of bits that are allocated to each bit. And so as the size of each weight is smaller, the size of the whole model is smaller. And so as the model is smaller, it's more energy efficient because every operation that involves the weights will be cheaper. Then you have the distillation. So here, this is rather for the training part. So the idea is to train a small model from a large model. And so in the end, as you get a small model, it will be more energy efficient when you will run an inference. Then you have fine-tuning and transfer learning. So the idea is to reuse basically pre-trained model and to pimp them to suit your use case. And so this is especially relevant when you use a large language model because you have a repository like Hugging Face that provides tons of LLM. And so you don't want to retrain LLM from scratch. So you want to reuse some existing model, but possibly you might require to pimp them for your application. And there are also a sparsely active mixture of expert-style models, which means basically you have a network that determines what is the best pipeline to run your inference depending on the question that you're asking, which is actually a good idea because for some problem, a neural network is not necessarily the best option. Okay. So now another angle could be to find efficient implementations. So those improvements can be at several levels. So for example, at the hardware level. So for example, you have Sohu, which is a firm that produces dedicated ASIC for transformers. So their statement is that everything is transformers. So they built dedicated ASIC to run transformers. And so they claim that it will be more energy efficient. You have also techniques to improve the training itself. So for example, you have Green Trainer. So they claim that they enhance the back propagation. And so you save 64% of floats. You have also some interesting paper. So this one is rather for Yane, who is here. Yane, hi. No, he's not listening. He's in the background. So which is named Addition is All You Need. And so the idea is rather than relying on the standard multiplication that you have in your kernel or rather in your CPU, you will define a new multiplication that is based on addition, which is significantly cheaper in terms of operation, which is accurate enough to provide you the result that you want. And so the author claims that if we would have this kind of approximating multiplication, we could have a significant energy savings. And then you have also interesting architectures. So for example, SNN, so for sparse neural networks. And so the statement is to say, okay, usually when we train a neural network, the average degree is quite high, which means you have a lot of weights, which means it's hard to train. And here the idea is to mimic what we have in the human brain, so a less dense graph of neurons. But of course, because the structure of the graph is less regular than what we tend to have usually, we have to revise the way we train those networks. And so Neural Magic is a firm that proposed a new way to train those neurons. And since many papers pretend that they can do significantly better than Neural Magic. But what is interesting is the way they approach the system. So basically in a standard neural network, for example, you tend to run layer by layer. And so this is so you have to weigh the previous layer before running the next layer. Rather than here, you slice the network in a horizontal manner. And so you have an asynchronous exchange between each part of the neural network. So this is during the inference. And so I can't explain you all the detail of their approach, but if you are interested by say another approach to train this kind of architecture, I would recommend you to look their talk. It's very interesting. And basically, because in the end you get sparse neural networks, so first the model is smaller, but you can actually once again rely on quantization and pruning to optimize even more your neural network. So now some example at Nokia where we try to do the thing right way. There is AVA. So this is a system. So basically the idea is when we use AI, do we get a good enough handprint so that it's worth to run AI for this use case? The idea is you have to consider the footprint. Okay, it's costly to run an AI, but if this is for a valuable use case, I don't know, for farming, for transportation, or anything, and you trigger significant optimization, maybe it's worth. And so, for example, in AVA, the idea is to shut down the devices in an efficient manner. And so the author claims that we can save 30% of energy by doing so. So actually, it's important to know. So I would recommend also a talk made by Jacob from ETH Zurich. So this researcher explains that when you run the internet, a significant part of the energy consumption is actually running the devices, not exchanging data, but just running the devices, which is, in my opinion, a problem. Also, so you have carrier shutdown using Bayesian learning. So once again, it's a technique to optimize the way we power our antenna to save energy. When we use energy, so as I said, you have to cool the devices, typically using water cooling, but this hot water could be used, for example, to heat residential homes. So this is something that we do at Espoo. And then we have some reuse and recycling program, which is, in my opinion, the most important point, actually, because I've watched a presentation that explained that in data center, we recycle less than 1% of the hardware, which means that whenever we change the hardware, we send it to the Ghana and it stays on the beach, and that's all. So in my opinion, it would be the main lever, actually, to think about how to reuse our old device to extract the material that is inside and reuse it to build new devices. And so this is the transition to Nokia Circular Services, of course. There are also frameworks that are here to help you to design an AI system with a design that helps you to have assessment about the energy footprint. So this is important to think about this in advance before running the project, because after this is harder. And finally, we have some responsible implementation. So for example, we have a project which is named DeepRX, whatever it is, that got a very significant energy saving by using knowledge distillation. We have also some people that are working on a large language model. So they reuse existing models. So this is all this training that is saved. And then they rely on distilled model to save energy. Okay, so some recommendation. So what you could do at your own level. So if you are a platform, so you could think about the hardware that you propose to your clients. So you should propose accelerated platform with optimized cooling, and more importantly, deploy in country that rely on carbon-free energy. As human beings, what you could do is to think about the way we consume AI. So there are workshops that are here to sensitize the people on those topics. So for example, la fresque du numérique. But I think that as researchers, we have to always keep in mind the rebound effect that could be triggered by our own research. I think, in my opinion, that green solution will become more and more a selling argument. I hope so. And also, as researcher, I think it's important that in our paper, we put the light on the energy footprint. So if you design a new AI system, if you propose a new AI-based system, you should provide some KPIs that say, okay, it consumes this quantity of energy. This is important. And so actually, there are famous conferences that run tracks to encourage people to go in this direction. And finally, I think that unfortunately, green AI is not only a research problem, but mainly an economical and a political problem. I think that at some point we will have to constrain and say the budget is this. And so when the budget will be very small, this is where optimized model will be very important, because the question will be, what can I do given this budget? Okay, so here are the questions that you should ask yourself before considering AI. Why do I run AI? So in particular, is there a better solution? When do I run AI? So in which situation? Is the handprint significant? But also, you might have consideration about the status of the electrical grid. So actually, there are some tasks that you can postpone, in particular the training. And so it's better, of course, to use it when the grid is less solicited. Then there is the question of the where. So what is the underlying hardware? Where is deployed the data center? So of course you should prefer countries that use carbon-free energy. I think it's worth to be very careful about greenwashing. So in particular, Microsoft Azure or Microsoft in general tends to say we try to do the things the right way, but in the meantime, they help the fossil energy industry to find new spots where to drill fossil energy. So I think it's very important as consumers to be careful of this and to choose what we buy consequently. As a researcher, we have to think on the way we produce our AI. So we should prefer modular design, and in particular, this will help to reuse existing models, like those provided in Hugging Face. You should prefer small model, and so Google, for example, is designing Gemma, which is a small model. It's important to note it. So it's good because it will be cheaper. The question that we must always ask is, what is the final goal? Is if in the end we run the model on more and more devices, maybe we will have a rebound effect. So we have to be careful on this. And finally, you should monitor the energy consumption of the model that you consider. So maybe you hesitate between 3 or 4 models. What is the best one? So maybe the result is more or less the same, but one is significantly cheaper in terms of energy. So in this case, of course, try to use this one. And finally, and more importantly, and so this is general to IT in general, you have to do the thing well. So efficient workflows, efficient implementation, because in the end, this is the problem. Okay, and that's all. And so if you have questions, I will be happy to answer.
Any question? Start with the student. I think you start back there. Okay, I'll send it as soon as I'm done. So you mentioned at the beginning, and I agree with that point, that sort of a lot of the cost is now shifting to the inference part, the user, right?
Right.
And you also made the point that the results we get from the AI-powered sort of search engines are so much better and so much more useful than what we had before, right?
Right.
So, and you also mentioned the rebound effect, right? So people are going to, and especially if it's now the default option, I'm not going to go back, right? So what are the, and I also would argue that this is mostly an economic problem. It is a technology problem, but it's a social plus economic problem, right? So how do we build social and economic incentives that can sort of essentially steer the users towards sort of doing the right thing while essentially, not harming the businesses that want them to spend all the time and money?
So that's a very good question. This is the question, actually. It's the question. So in my opinion, the main problem is that AI is most of the time free. And so we use it every time, even for irrelevant purposes. I think that if we add a very, very, very cheap cost, I don't know, 1 cent, for example, whenever you run a query, I think that you will significantly decrease the number of queries, I think. It won't happen because, of course, the people that promote AI, that sell AI, want more and more users. So they don't want to put a barrier for their clients. Maybe at some point, because the regulation will say this AI provider consumes too much energy, it won't be worth anymore to propose AI for free. And so this, I don't say this is the answer. I don't say this is what will happen. I don't know, but I think this is something that could happen. If the legislation and the politics says now you pollute too much, you have to pay more, then necessarily this will be repercuted to the clients. And you can see this, for example, in the plane industry. So, for example, Europe is saying we will force the airlines to pay more because they pollute a lot, etc., etc. And so what happens is this is repercuted on the price of the ticket for the client. And so I think this is the same here. It's my opinion, but maybe it's not the right answer. No.
Have you studied about federated learning? Do you think it's a good alternative for training models without needing the need to construct a new data center?
Sorry, could you repeat?
Federated learning, like you can train a model with a collaborative way. So everyone's trained locally and we aggregate the model. So we don't need to aggregate the data in the data center and run the data center because we already have the computing power.
So the question is, I can't answer because you would require to do an energy assessment. What does it consume? Is it worth or not? So I guess it depends on your federated learning approach. And that's why I say that you have to monitor what you do. Because if you don't monitor, we don't know. Maybe you will use, I don't know, 10% of your CPU, maybe 100%. Maybe you will have a rebound effect because suddenly you will make available a lot of resources that previously weren't available. So it's hard to answer to this question. It depends on your use case. It depends on the intensity of your solution. And so without monitoring, you can answer. And so basically, the entry point as a technologist is you have to monitor and provide KPIs. And then according to those KPIs, you can switch the button, the lower, the upper, as you like. But otherwise, you can answer.
Okay, thanks a lot. And I have another question about the carbon footprint of building new capacity, because you mentioned specialized hardware for inference or maybe training, but you need to build it, so it has a cost.
That's right. So once again, you have to evaluate, is it worth or not? It's always the same question, because here I'm talking about the current technologies. But we can imagine that in the future, we will have new technology. We have people working, I don't know, on quantum computing. They will probably design new things. What will be the impact of this? Will it require new hardware? Will it save significantly more energy because tasks that were very complicated will be solved very efficiently nowadays? It's very hard to answer. Once again, you have to monitor. This is the question. Without monitoring, you can answer. And also, I would add, you not only require to monitor. This is something I forgot to put in the slide, but you have also to standardize. It's very important because one problem is when you break something, you tend to change the whole material. I over-exaggerate just to make you understand, but if everybody has the same port, the same alimentation, the same memory, the same whatever, we could more easily change and upgrade our computers. And so this means that we would harvest less resources. And it's important to mention that here I'm talking about energy consumption in AI, but actually the true footprint is in the manufacturing and the hardware manufacturing. So this is basically all the new computers that are the problem. So one question that we might raise is, can we do better given the current architecture? It would be nice. Instead of running about a small percent to improve a model, but that this requires to change your whole infrastructure, which is not reasonable. You see what I mean?
Which one?
And I would like to thank the question because this is where we have PhD students and this is very good. So I encourage the other students to ask questions if they are. Yeah.
Yeah, so I was just to build on. I think unfortunately, the idea of using, fewer neurons or less quality or an old fashioned model just isn't going to happen because of competition.
Yes,
Right? I
unfortunately,
mean, no
you're
one is
right.
going to choose to do that because companies want their model to be better than someone else's. And unfortunately, a lot of these models are actually very, very similar to begin with. So however, I do agree that standardizing measurement is potentially very powerful, but these things have to be turned into incentives, like,
Right.
if we could come up with some kind of like, that we have trust certificates, right, for people who do a good job with security protocols, and you know whether a website has that, says their security certificates or not, and trust, badges and so on. And if we could have that and have it be standardized and be very visible, then, if I'm going to go run a very simple query, I can choose, right, maybe?
Exactly.
And so I think standardizing, but also converting to a badge that, or some kind of thing that gets labeled is very important. But we should spend too much time hoping that people will choose less powerful models, because companies aren't going to do that.
I think
Yeah.
you're perfectly right.
Yeah.
You have in one hand to say here you are doing bad thing, I will penalize you, but also I will encourage you to do the right thing, and so it applies anywhere in the chain. So the hardware manufacturer, the AI provider, the consumers.
Yeah.
That's right.
Also, thank you for this talk, because I like very much that you said the whole problem of what's going on broadly in the industry, and then you're
Thank you.
talking about what you're doing. It's a good strategy, good vision talk.
Thank you. Thank you.
Thank you. Thank you.